On your screen, you will see the instructions to log into your lab, but that should take you right through, get your lab started, and we'll get started here in just a couple minutes. Thank you.
All right, so for the few folks out there, thank you very much for joining us today. VectorUSA, it's a pleasure to bring in the Silver Peak team to talk about SD-WAN connectivity, a recent acquisition by Aruba Networks. Us being a great Aruba partner, we're happy to have them on board. So we have a technical deep dive today. We have some of our engineers online as well. So at this point, without wasting any more time, I will turn it over to the Silver Peak team and we'll get started. So thank you very much.
All right. Thank you, Curtis. Thank you, everybody, for having us today. So the first thing that I'd like to let everybody know is I'm here with my counterpart, Joe Thalander. You don't see him just yet. He'll be presenting. We'll be switching off the different sections here in presentation, so you'll see him here in just a little bit. But Joe is the local field SE here for Silver Peak, and I am the channel SE. So for those of you who are part of VectorUSA, I'm your technical resource, as well as Joe too, but Joe will be mostly working with your customers, right, more than on the partner side. So I'll handle things if you want more in-depth training, things like that, you know, initial talks on how you might design something. But once you actually get involved with the customer, that's when Joe would get involved in designing specifically for their network, helping you implement it, those types of things. So thank you for joining the class today. It is really meant to be as interactive as possible. This is a hands-on lab. So you will actually, you know, if everybody's got their lab spun up, you'll actually go through exercises where you're actually, you know, configuring appliances, deploying appliances, making configuration changes, seeing how the Aruba Edge Connect platform works. So you might hear me say sometimes Silver Peak Edge Connect. You might hear me sometimes say Aruba Edge Connect. It's because it's kind of old habit for me. Joe and I have been with Silver Peak for a long time, many years before the Aruba acquisition. So I know me personally, I won't speak for Joe, but I know me personally, sometimes I just say Silver Peak. I really mean Aruba Edge Connect now. So so just if you hear me say that, that's sometimes kind of go back and forth.
Rebranded to the public as well, so it's Aruba Edge Connect
Yes.
all the way. So Silver Peak isn't supposed to be in the vocabulary anymore.
That's true, yeah. But as you can see, the person who prepared this deck said Silver Peak / Aruba. So it's like, yeah.
As Silver Peak, and that's, you know, when you say that.
Right.
Aruba Edge Connect doesn't have the recognition yet in the market. So
Exactly. Yeah. Yeah. So the way this format is going to work is essentially we're going to do you know, a short presentation, you know, of a section of information of topics, and then what's going to happen is then you in your labs will actually go and perform you know, the functions and tasks within the information that we provided. So I believe there's like there's four separate sections. So Joe and I will rotate off on that, but we'll go ahead and get started here. And again, any questions that you have, feel free to just either post it in the chat or just break in, say, hey, unmute and just ask the question. We're happy to accommodate you either way. So the first thing we want to do is just give a little bit of an overview of SD-WAN and why companies are adopting SD-WAN and making the transition from what we call legacy routing environments, legacy WAN environments, into what is known as SD-WAN. SD-WAN is a pretty generic term. It's pretty broad. Typically, it stands for, you know, software-defined WAN. So today, or in the past, right, we've done everything via CLI as network engineers. So we've had to touch, you know, appliances one by one, and it's not on a software basis. We don't have a centralized UI, or we haven't had a centralized UI where we can go and make configuration changes where automation is in place and doing a lot of the manual tasks for us. Everything in legacy networks is a manual process, and it's appliance by appliance. And so these are some of the challenges that are driving that. One of them is the total lack of automation. I think it's probably the biggest one. with SD-WAN, with an SD-WAN vendor or an SD-WAN product like Aruba Edge Connect, a lot of the manual tasks are just done under the hood for us now, right? So essentially, and you'll be able to see as you work through the labs, we, instead of having to go and configure, when we say like an IPsec tunnel, all of the commands, right, that we used to have to as network engineers, you know, crypto ISACMP, blah, 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 and crypto IPsec, and you have to set every little detail. Essentially, the goal for the Aruba Edge Connect platform is we tell the orchestrator what we want our network to look like, and then it goes out and builds it for you. So essentially, all we're saying is we want IPsec tunnels between these two particular sites, and then it goes and does all of that configuration for you automatically, right? And you don't have to worry about, oh, did I misconfigure this on one appliance and this on that appliance, because it's going out and doing it for you. Again, simplification of WAN architecture, right? You know, simplify, we work as network engineers with multiple routing protocols, all kinds of different stipulations within the network. You know, how do we make these things active, standby? The idea is to simplify that, right? One of the big, I think, proponents of SD-WAN, why companies are adopting SD-WAN, is companies are beginning to move assets into the cloud, assets and services into the cloud. And so how do we reach those, right? As companies always, or in the past, right, the past 15, 20 years, we've designed a legacy network or a legacy model where all of the apps were housed centrally in a centralized data center. But now you have these apps starting to break away, right? Oh, maybe this app's hosted in AWS, or this app's hosted in Azure, or this is a SASE or a SaaS service like Office 365. How do we, you know, steer those applications where they need to go? And in a legacy environment, that was, I'm not going to say it was impossible, but it was very difficult to do. Now you can route by application. You could say, okay, well, I want these apps to go back to my data center. I want Office 365 to go directly to the internet, and I want these other applications to go to AWS. And it's very easy to do that. And it's very easy to make those changes now across hundreds or thousands of sites all at one time. Okay. High infrastructure and connectivity costs. At the beginning, you know, 5 or 6 years ago when SD-WAN first came into play, that was one of the big proponents, or one of the benefits I think that was touted the most. How do we get away from expensive MPLS type circuits and onto broadband internet circuits, right? So we all know MPLS, we were paying a lot of money as companies for MPLS for those guaranteed performance, right? Especially for voice, video, real-time apps. You know, we needed those guaranteed latency, you know, loss, jitter, that the internet doesn't provide, right? When you go and get a broadband internet connection, there are no SLAs tied to it. It's basically best effort. So, however, with software-defined WAN, when now we can actually look at those links, know what their performance is in real time with regards to latency, loss, and jitter. And if you actually have multiple internet links, we can use them at the same time and condition them so they perform as well as an MPLS link, right? So now you have companies that instead of paying $1,200 for a T1, right, or, you know, even more expensive for higher bandwidth, they can go out and get an internet connection with 100 meg up, 100 meg down for maybe $50 a month, right? And so, but I will say, I mean, that is definitely possible. That's not any more the leading case, though. Most companies are not doing it necessarily to save the cost over MPLS, because we still have customers that have stayed on MPLS. It is a benefit, but I think most of it, the customers choose us because of ease of use for their teams, right? Like we were talking about the automation that the Silver Peak, the Aruba Edge Connect platform brings, the ability to steer applications intelligently very easily, the visibility that they get from the platform. Those are actually, to me, what I've seen to be more of the drivers for why customers are adopting SD-WAN, because it's a better way of doing things. I like to use this example. EJ says it makes me sound old, but I am, so I'm just going to say it. So for those of you on the call, EJ Wells is the channel account manager. He's my partner in the territory. You can't see him, but he's here. But it's kind of like, remember when PCs first came out, you had DOS, right? People were using DOS, remember? And then Windows came out. And all of a sudden, it just made everything easier for everybody. And that's what I compare, that's what I like to say SD-WAN is doing for network engineers and network teams right across the world. It's like going from DOS and the old way of doing things to Windows now, right? And that's the kind of jump that SD-WAN brings. So again, network complexity is out of control, right? You know, we have costs going up with MPLS, right? How do you do things if you have a failover, right? You know, what is the automation involved with that? We still have a lot of customers that we run into because the legacy infrastructure and the way you had to configure things, it didn't lead a lot to automation. And so when you had a failure on a link, sometimes they had to go in and manually switch over, right, traffic from that dead link or that broken link to a new one. And now all of that's automated. And essentially all of the complexity, right, of like saying this application needs to go here, this application needs to go there. If this is a particular case, you know, we need to like switch links. We didn't even have the ability hardly. I mean, I won't say it was impossible, but it was extremely difficult. You couldn't say, hey, this particular link, we're seeing 2% loss on it. We know that that's impacting performance. Let's use the other links that we have available to us. Now you don't even have to think about it, right? The Edge Connect solution, the Aruba Edge Connect solution, does all that for you out of the gate, right? Out of the box, under the hood, things that you don't even have to think about anymore. And so, again, that's the benefit, right, of I think why people are moving to SD-WAN, exploring SD-WAN solutions for their company, because when a network team doesn't have to worry about all of those things, they can quickly get their network up and running. They can maintain it in less time than what it typically takes. They can troubleshoot it faster. So then they can actually get on with other things rather than always being bogged down with the details every day. Again, I think, you know, anybody who has been around for the last couple of years has probably seen, you know, graphics like this where you know, this particular company here, or this illustration, it illustrates the typical topology that we've had in corporate networks, right, for the last 15, 20 years, where everything was housed in the data center and everybody's backhauling to that. They even backhauled their internet connections, right, back to the data center because typically you didn't use the internet for business back then, right? You know, and if people were going to YouTube or things like that, you didn't want them to. And so now with applications moving to the cloud, this model doesn't work very well anymore because the latency created by having to backhaul to a centralized data center and then go to the internet impairs performance, right? So, for example, if you have like a centralized data center where your employees are reaching applications, let's say in Denver, Colorado, and then you need to get to the internet to reach Office 365 or some other SASE service like maybe Salesforce.com or Box or something like that, and you're in Alaska, and instead of being able to go directly to the internet in Alaska, you got to go all the way to Denver, Colorado first and then to it, right? That impairs performance. And so we know that this model just doesn't work anymore. However, companies can't change overnight. They still have a lot of their applications in the data center, so you need the ability to be able to say, hey, I need this one particular application to go directly to the internet while all these other applications are still going right to our centralized data center. And so anyway, all of these different things, right, are contributing as to why companies are exploring SD-WAN. Why SD-WAN is becoming and will be becoming the de facto standard, right, in network WANs over the next several years. Again, total lack of automation. Again, right? This is what we used to see as network engineers. I mean, we actually still do see because we still work with many companies that are transitioning into an SD-WAN platform. But this is what that manual site-by-site CLI-based management looked like, right? Command line, going in and doing this site-by-site, right? So what it all nets out to is SD-WAN. I mean, all of this is just, it's a better way of doing things, right? It's a network that is built to route by application, not just by source destination IP like we're used to, right? And it's meant to replace many of the functions that are done at a branch, right? So many times, right, if you needed WAN optimization, you needed a WAN optimization appliance. You needed a traditional router, right, just to provide connectivity, right, to resources such as the internet or MPLS or things like that. You needed a firewall to perform security functions, right? One of the other purposes of SD-WAN is to consolidate those into one box. And not only consolidate it, but to make it to where it can be implemented very easily, right? Much easier than what you had to do. You don't have to learn all these different technologies necessarily anymore. You don't have to do it on a CLI basis. It's a nice UI that's easy to use, right? And you can do everything from that UI, from configuration, management, troubleshooting, reporting, right? Simplifying your network and and managing it. Okay. So let's talk a little bit about what the platform is comprised of. So it's really two main parts. They've added a third one here, but really it's the top two. So where you see the Aruba Orchestrator, that is the heart, right, of the solution. That is the brains. That's where you do everything from configuration, management, right, troubleshooting, reporting. You can get all of that. You do all of that through the Orchestrator. There is no going to the CLI on these appliances anymore, right? Everything is done by the Orchestrator. If you need to make a change across 1,000 appliances, right, you do it in the Orchestrator and it'll do it for you, right? Okay. So that's the first main component. Now the Aruba Orchestrator can be on-prem. So in other words, you as the customer can host the Orchestrator. It's just a VM. You can host it in your own environment, or it can be hosted as a service by Aruba in the cloud. So it's your choice as a customer. A lot of people like the Orchestrator as a service because when it is Orchestrator as a service, Silver Peak or Aruba Silver Peak will now manage that instance for you all on the back end. So all of your backups, if there's any problems with the Orchestrator, right, Aruba's DevOps team will take care of that for you. Whereas when it's on-prem, you have to manage that yourself. You have to manage all the backups, make sure that's working for you correctly, all that stuff. So the next main component is the Edge Connect platform itself. So this is the software, right, that essentially is our product. Now that can be in 3 different form factors, right? You can get physical appliances, and to be honest with you, most networks, right, I would say 90% of them have our physical appliances at their locations, right, replacing the edge routers that are there. And so that is definitely, we have sizes all the way from ultra small. We do it by shirt size. We have ultra small, which is about the size of an iPhone that some people like. We have executives that will go home, right? And they want to be connected directly to their network, right? They'll bring those home, plug it in, and they're up and good to go. All the way up to data center models such as the extra large. It can go up to 25 gigabits per second in throughput, right? So, and then we have the mix in between. The same software is available on or as a VM. So we do have some customers, perhaps they don't need the physical appliance. So maybe they're running on a hyper-converged infrastructure, right? They can put that same software, just download it as a VM, put it on whatever platform they're using, and it's the same exact thing. That's one thing we love about the Edge Connect platform. Whether it's physical, whether it's virtual, it is the same software code. There's not different codes for each one. So you're using the same exact product all the time. And then there's what we call the Edge Connect Cloud, which is essentially just our software is available in the marketplace of the major cloud providers, right? AWS, Azure, Google Cloud, and Oracle as well. So those are the 2 main components. Now, they do have a third component on the list here. It is what we call Boost, WAN optimization. So Silver Peak back in 2004 started as a WAN optimization company, okay? And that's specifically to move large amounts of data over long distances, right? And so that capability is still part of our product, right? We have not let that go. So there's no other SD-WAN company out there that has integrated WAN optimization, right, into their product as well. So with the Edge Connect product, you not only get the SD-WAN features, but you also have the WAN optimization capability as well. So that's why it's included on here. It's just something that we want customers to know, that we still that customers, Edge Connect customers, they still have the ability to utilize WAN optimization where and when they want it. Okay. And again, this is just showing some of the screenshots for the Orchestrator that you guys are actually going to get in here in just a couple minutes and begin working with. And again, just more of just some of the different things that we incorporate within the product. I think the main thing to notice on this particular slide is the business intent overlay. That's what you're going to be working with a lot in this workshop, because the business intent overlays are the heart of the system in Orchestrator. It's where essentially you configure how you want applications to be treated and routed, right, within the platform. The business intent overlays also control who they build IPsec tunnels to and all of the automation that comes with that. All right, so now here's where we hit lab modules 1 and 2. So each of you should have received a lab guide, or a link to the lab guide in the emails that you received. I believe they were yesterday. So if you could just go ahead and follow that through, just through modules 1 and 2, stop after module 2, and we'll pick up from there. But what these modules will take you to, or take you through, is an overview of the Orchestrator, getting it set up, and creating templates, right, to push out for configuration. So we'll give you about 30 minutes here for you to go ahead and go through that. Again, if you have any questions or anything, please let us know either via chat or just unmute and speak up, and we'll answer your questions as best as we can. Thank you.
Okay, so lab modules 1 and 2. We got to play a little bit with the Orchestrator. We got to play with templates. Who can tell me something that was surprising to you or that you learned by doing the lab?
I was surprised with the detail on the traffic for the total WAN, and that you can actually go inside access waiting column and change it directly. I thought maybe you'd have to, do some other steps, but that seems very efficient to me.
Yeah, that's a good feature. And the general concept is when you're orchestrating, right, you're not doing things one at a time anymore. You're doing things in a really global and efficient way, so that a lot of those kind of changes, you'll have happy surprises like that more than once as you go through the labs and you get more familiar with the system. Who else has a comment or a learning or feedback?
I'm not the most technical guy in the room, but it seemed easy enough, right? It seemed point, click, go, right? So
Point, click, go. I like that quote. We're going to use that one. SD does not stand for software defined. It stands for self-driving. Well, is there anything that didn't make sense or something that was confusing to you?
Not
Good. No confusion. Sorry, come again?
Sure, not necessarily confusing. Just getting used to the dashboard. Like you would in driving someone's new vehicle or a new vehicle itself. But I think that just comes over time with frequent use.
Yeah, and let me echo that one. I mean, I come to you as a very old router jockey. I mean, I did 19 years with Cisco before coming to Aruba, and it is a little bit of a mind bend, right, to sort of get used to the GUI. There are a bunch of things that you can use as little guideposts, and I wish I could wave my wand over an Orchestrator right now, but anytime you see the letter I, a blue letter I with a circle around it, click it, because that will give you, it's sort of like a manual, like a built-in help system that's context sensitive. So
I see.
let me invite you, to your point, it's hard to sort of find your way around the GUI at first. Use the little I button. Another thing that we don't cover in the lab, but you all should know, there's a little box that says search, right? At the top of every, like above all the menu items, it says search. So if you want to do something and you're lost in the menus, because the menus get a little bit deep, there's like 4 top levels and then there's 2 or 3 next levels down, and some of them have 15 choices. Just type the word, like, or a fragment of what you're looking for. So if you want to make a BGP change, just type BGP, and you'll see all the, it's a text search through the menu choices that give you all your BGP choices. You might want to try that now. Or you could do the same thing for tunnel, right? If you type the word tunnel, you get all sorts of little tunnel-related stuff. You can check tunnel status, you can, you can modify tunnel exceptions. There's all sorts of stuff you might want to do with tunnels, but if you want to, if you're not sure where to find it, and this goes even down to low-level stuff. Like if you type DHCP, you'll see all the DHCP stuff you can do. So just a little tip, a little word for the wise. The lab probably doesn't help you do that, but just test it out and try a few things. You'll see what you get. Any other feedback? We want to keep it conversational. So tell us what else you liked or what you didn't like.
Well, nothing in terms I didn't like, but I noticed though, for example, if you type in SNMP, that currently there's enabled version 1 and version 2, and actually version 3 is now the best practices way to go. Maybe it's there and I'm missing it, but yeah, I don't see it. And the reason why I asked is that we're currently configuring some Aruba switches, 6300s for a client. So I was wondering if that's in the orchestrator. It may be. I don't see it.
No, that's a good question, and you caught us, because there is no SNMP 3, version 3 that I'm available of, and our engineering has kind of decided that while SNMP is important, we're leaning more towards like,
I think it's like priorities, right?
right. Well, but like sort of from monitoring perspective, we're leaning a lot more towards, let me get it right, like NetFlow and IP fix is the kind of more modern than SNMP ways of managing those things. But
I see.
again, this is like a philosophy thing, and I hear you loud and clear that a lot of customers still like SNMP and they want SNMP v3, and we don't have it. So just being transparent with you about that. But good feedback.
All right, I appreciate it. Thank you.
Hey, you're welcome. What else?
I see in the SNMP templates, there is SNMP, SNMP v1, v2, and SNMP v3 is another one, but it doesn't have the same options as the other one. Is that just sort of like a beta implementation of sorts?
Yeah. So now I've got to ask some annoying questions. We don't really need to go down a lot of time on this, but it depends on like what version of the orchestrator we're on for this lab. So can anybody read me in the top right corner of your lab, or I'll just walk down here and look at it on yours, if you don't mind, Curtis.
Yeah, not at all.
8.1, 8.10.10.
Okay, 8.10.10. So that's relatively up to date. But this is another thing that you're going to have to sort of get used to. I'm going to take your question, use it to make a point, and then come back to your question. This is software defined, kids. So this is super dynamic. What you see in the orchestrator is changing all the time.
Right.
And so it's not like in the old days when you downloaded software onto your router and that was it. Until you did something else, until you proactively put the next version on, things were frozen. No, right? So orchestrators, we're rolling a new orchestrator like, what, every quarter or better? Like an updated version. And so when I say SNMP v3 is in there, well, I know it wasn't as of a couple of releases ago. Maybe they're doing something new. I'll even own the fact that I should know this and don't about exactly what is in and what is out on this particular rev. So this is another little mind bend from what you're probably used to. Both the appliance software and the orchestrator software are getting updated a lot. And this is bad because the ground is shifting underneath your feet and you're like, whoa, I don't know. But it's good because you get new features and you get new bug fixes really, really fast. And you're not stuck in that, I'm going to call out Cisco because I know it well, like the Cisco mindset of, yeah, we're going to put that new feature in the next release train that's coming in 18 months. I mean, we're not living that life anymore. That's not the way we want to play. So back to your question about SNMP v3, can I take a note and respond to the team about what the exact roadmap and details on all that is? And again, apologize for not being 100% on top of it, but things change fast. And so maybe there are some V3 capabilities that I wasn't aware of. Okay, so my presentation classes always say question to the void, so I'm going to keep questioning until I get silence. What else?
I just want to add, that's all, I think that's good what you just added. It's not a showstopper, and this is what I always tell my colleagues about automation. It's always evolving. Just because a certain feature isn't there now doesn't mean it won't be there in the future. And the upper echelon becomes aware of this and evolves along with what clients are seeking as important. So in regards with SNMP version 3, it will happen at some point. It's just not there at the moment.
Correct. Yeah, exactly. Thanks for that.
All right.
Who else has a question or an observation? Yeah, question to the void. Good. Let's go to the next slide here. Yeah, okay, this is all the stuff. Overlays. So did anybody skip ahead and look at the overlays? Did someone maybe just see this screen or try something out, or did we all just hit the stop sign at lab 2 and then say we're going to wait?
Instructions perfectly, so.
Okay, we got Curtis the rule follower in the room. Anybody else?
I'm like Curtis, I follow the rule.
Okay. Well, let's kind of work through this slide. I think it's a build, so let's see what happens next. Can anybody give me a hunch or a guess at what is an overlay, or what does an overlay do? There's a little picture on your screen to help. Okay, so an overlay. Tell me if I walk out of your box. Am I visible over here? Can I wave at this?
The camera follows you. It should follow you.
Ah, okay, so I can wave at the screen and you can see what I'm up to. Yeah. So an overlay. An overlay is really one definition of a network. It is not the network. It is not your network. It is a network, right? So for a network, for some set of applications or some set of traffic that we're going to define in an ACL, this is how the network is going to work. This is like kids on a playground making the rules of the game. For this game, for this traffic, we're going to be in high availability mode. Don't worry too much about what that is for now. Just know that there's other modes. There's high throughput and high quality. But we're getting, for this one, high availability. For this one, full mesh. Every site can talk to every other site, right? For this network, we're defining SLAs for our loss latency and jitter. 1% loss, 400 milliseconds latency, 200 milliseconds jitter, right? That's the rules for this network. For this network, we're saying we can use 3 circuits, MPLS, Internet, and LTE. Any one of those circuits in play, we can use them. You got a satellite circuit, can't use it. It's not in the game. Rules for this one say no satellite. It's not listed here. Next, we want to say, what about, so these rules, I should mention also, only apply to what kind of traffic? Site-to-site traffic, like SD-WAN traffic, or internet traffic. There's only 2 choices. This box here, site-to-site traffic, right? That's if you're going from one silver peak to another silver peak. One of the sites on your network to another site on the WAN. The second box over here talks about internet traffic, okay? So what if it's not bound to one of your private internal RFC 1918 addresses? What if it's bound to Zoom, RingCentral, 8x8, WebEx, Salesforce.com, you pick it, something out there on the internet. There's a whole set of rules that we're going to make that define behavior for that kind of traffic as well. Okay? And then the last thing is some of these little overlay defaults, like are we going to try to do QoS? Are we going to try to do WAN optimization? Are we using a zone-based firewall? And if so, what kind of zone-based firewall rules do we want to have in place? All right, so that was a lot. And there's more. Like if you drill down, there's a whole next level of detail underneath this. But what I want you to take away is we made the rules for one network. In the one network, we defined the kinds of traffic, we defined the kinds of topology, the circuits we can use, what to do with internet traffic, and some stuff about QoS and optimization. Now, if you thought that was a lot, we're not done, because guess what? We have another overlay. Is this the network? No, this is a network. So we have another whole network. This is the great thing about software defined. You used to make those decisions once, and you were stuck with them, right? Now you get to make them lots of times for all sorts of different traffic. So this is a mind bend. You're like, whoa, I'm not used to this. I can't have a full mesh and a hub and spoke at the same time. Yeah, you can. Different applications need different kinds of topologies, and they need different rules about what to do with their internet traffic, and they need different rules about what to do with their circuit, which circuits they can use, right? So now we're going to make a whole second one. I'm not going to make you run through all question.
If I'm understanding it correctly, again, traditional wide area network, right? I've got my MPLS, I've got my setup, I've got my point-to-points, whatever. Taking all that out and doing these overlays based off the application. So the network will behave differently based on the application overlays that you're doing.
100% right. That's
Okay.
correct.
Got it.
If you couldn't hear that on the call, these decisions are being made application by application. So let me lean on this part over here one more time. This is an ACL, and you'll get to see this in the lab, right? This ACL says, what kind of traffic, what set of applications follow these rules? Different set of applications, different rules. Let me breathe and ask for questions. Okay, and then now, without, again, going deep into all the details another time, because that'd be boring, think about like what kinds of applications need different kinds of treatment. Like in this world, we've said real-time applications. What's special about real-time traffic? Priority, yes. What else? Latency sensitive, right? We need to set a latency SLA. If the latency gets too long, no bueno, right? And what else? Better never than late, right? Real-time traffic that comes late actually harms you. You're better off dropping it than trying to deal with it, right? What's special about these business critical apps? SAP, Oracle.
Well, theoretically, you're setting priority and quality on the network for those over everything else.
Right. These are the important traffics that we as a business care about. This is stuff that needs to be treated with gold service, These are our frequent flyers who we care a lot about. What's special about all this other traffic? The default overlay. This is the scavenger, the catch-all, the match-all, right? That usually what you'll see for a ACL for this guy is match everything, right? So we don't know what this traffic is. So we're going to give it kind of, this is the lowest member of the food chain. He'll get whatever bandwidth is left over. He's not going to get super special loss latency and jitter treatment. If it's going to the internet, here's another little special thing we can do. Some of this traffic we can go, yeah, we trust Office 365 and Workday and Box and Slack. Just let that stuff go straight to the internet because there's built-in encryption, right? Your Office 365, you log into it from Starbucks all the time. Do you need a firewall? Nah, it's good. Slack, you do it from home, you do it from work. There's a whole built-in SSL layer, right? Do you want to encrypt that? Nah, let it go. Do you need a firewall to inspect it? Nah, we trust it. What about Facebook, YouTube, or anything else that might be in this, Tinder? Anything in the scavenger class, the match-all class. You better believe we're going to inspect that stuff. That's going to go through a cloud firewall or a local or service chain to a local firewall. And we're going to be pretty restrictive. We can have permit and deny lists associated with the scavenger class, like never, ever, ever let BitTorrent out, as an example, in or out. Make sense?
Yes.
Yes.
Okay. This is it. This is the heart of the system. If you get this, you get SD-WAN, and you'll be able to really effectively use these tools to manage your network and to do stuff you couldn't do before. All right, that last one was a cartoon. This is a picture of what you actually see in the Orchestrator, and you'll get to play with this. Notice that you can only have up to 7 overlays, 7 max. So you need to think a little bit carefully. They're a limited resource, right? You don't want to willy-nilly suck up, I'll create an overlay for this and this and this. You need to sort of think ahead of time. What applications are similar, right? What can we group together and treat with the same topology, bonding policy, internet rules, all that stuff? We have the whole next lab touches on all this. So maybe now is not the time for you to ask questions. Now it's time for you to just sort of go, I get the general idea and I get to play with it soon. But if you get stuck, we're here to help. All right. So now we're going to talk a little bit about how link bonding works. Anybody know what link bonding does? There's a picture here to help you.
I assume it's almost like an active-active connection where you're sending traffic down 2 separate pathways, right?
There you go, exactly. It's a bonding policy that says we're going to send for one underlay. What we call an underlay is like MPLS, Internet, LTE. We're going to create an overlay, bonds together all 3 of those into one logical circuit, right, that we defined on the last page using our business intent overlay, right? And now look what happens. We got 8 packets to send, plus this P packet. We'll talk about that in a minute. We got 8 packets to send. 1, 3, 5, 6, 7, they go down the broadband. 2, 4, 8, they go down the MPLS. On the far end, the other silver peak puts them back together and presents them to the application like nothing happened. This is cool, right? You get to use both channels at once. What's the P packet? Anybody know what the P packet does? Well, there's not even a hint on this slide. I'll just tell you, parity. P stands for parity. So the idea is we use the parity packet as like a sanity check. You've all seen like on RAID disk arrays. Parity allows you to rebuild a disk. If one disk fails, you've got data in parity and you put it back together from the surviving disks. This is the same concept. We're going to put any one of those 8 packets gets lost, the parity packet covers it. So this is a really fun thing to remember. You don't have to do 1-for-1 parity. You can, but you don't have to. And we're not mirroring. We're not doing RAID 1. We're not sending 1, 2, 3, 4, 5, 6, 7, 8 down this path and 1, 2, 3, 4, 5, 6, 7, 8 down that path. Why not?
Push congestion. Why?
Wasteful, waste bandwidth. Why else? It turns out not to work very well because this circuit is fast and this circuit is slow, or vice versa. So when you mirror them and you try to put them back together, now you're waiting on the slowest circuit all the time. Okay, why else? Because the way TCP works, right? How long are you going to wait before you declare a packet lost? Once you lose a packet in TCP, the window slams shut, your whole circuit, your flow slows down, and then you start again. So you don't really want to wait for the slowest circuit if there's a lost packet. You want to just go, boom. If I don't see this parity packet, that's one that I got to wait on in the longest amount of time. So this has been tuned up. This has been thought about a lot. And people, I think people underappreciate how hard this is. We get a lot of competitors who just go, yeah, we have path conditioning. We send all the data down both paths if you want high availability or high redundancy. Like, it don't work. It's really not good. It's not efficient. Okay, so the packets all pour out the far side. I'm going to digress now. We're going to talk about bonding policy. This is one policy where you say, okay, I'm going to use both links. I'm going to use them for data and parity. There's a lot of different ways to do this. There's a lot of ways to skin this cat. Which one is best? It depends. I don't know. It depends. Yeah. Depends a lot on your application, right? For real time, it's a much different answer than for high volume stuff. For high volume stuff, you might want to just saturate all your links, right? You might, but you might not. So we give you 4 bonding policies. And remember that the bonding policies are per overlay. So for each overlay, you get to say high availability, high quality, high throughput, and what's the last one? High efficiency, right? So you can do all kinds of things. Like some backup software, it already does all this stuff. It's got its own built-in parity and its own built-in checks. So you might not want the SD-WAN layer to do anything but saturate all the links, right? So you can do high throughput if you want to do that. No parity at all, zero parity, right? For some applications, you want to turn on parity. So then you go, how much parity? Do I want one-to-one parity? Do I want adaptive parity? Oh, this is cool. So think about this. Why do we send parity? Come on, you know, why do we send parity? Correct for loss, right? We talked about correcting for loss. What if you had theoretically, say you had a network with no loss, 100% packet efficiency? How much parity would you send in that network?
You would need to.
No. Let's say you have a really lossy network. So you're getting like 10% packet loss. How much parity would you send in that kind of a world? Not a trick question.
10%.
A lot, right? Because the more loss you have, the more parity you need to fix it and to overcome the fact that, remember,
I think it's a lot.
right? So it's a little bit counterintuitive. Like when you have a lot of loss, you're going, oh, I'm losing a lot of packets. It's inefficient to send parity, or it's costly, it's overhead, right? But that's when you want the most parity, when there's a lot of loss, because you don't want to lose a combination of data and parity that results in a real loss, a complete loss. So we have this thing called adaptive parity. One of these overlay policies will say, well, I'm going to watch the network. When the loss is at 2%, or let's say when it's like 0.2%, I'm not going to send much parity, maybe 1 out of 40. When the loss rate ratchets up to 2 or 3%, which is really high, now I'm going to send lots and lots of parity, up to a specified max, right? You can say, well, never do more than 20% parity. So there's a lot of little nerd knobs you can twist in here to make your overlay do what your application needs. Questions? You people on the phone, your eyes were all glazing over because this is overwhelming. Stop me.
No, you're good.
Okay, cool. Internet breakout. Anybody take a guess? What's internet breakout do for you? Somebody on the phone. You're smart guys. You know this. I'll give you a hint. They used to call it split tunneling. So internet breakout is just saying we're going to let some stuff get off of our network without going through a tunnel, right? So think about the bad old days when all you had was MPLS. What was your choice with internet traffic? Jason showed you a slide on this, right? You remember?
You bring it back to the hub, and then it goes out over the internet from there.
And then it comes back, and then it goes back, and people are all...
From the branch office and send it directly out to the web.
Correct. Exactly.
Wow.
Right. Now, first off, could you do this in the bad old days of MPLS?
Not without an independent IP drop at each of the remote sites.
Right. You still need that. There's no magic, right? You have to have a connection to the internet.
Yeah.
But if you have, so if you have an MPLS only network, this sort of doesn't apply to you. But in the modern world, people are all like, well, I want to go straight to the internet. Why shouldn't I go straight? Well, maybe I don't. Because some applications are like BitTorrent, and I want to inspect them, or I want to give them a heavier security touch. So the point of this is internet breakout gives you all the tools you need to decide. Straight to the internet, extra inspection and then to the internet, backhaul, or just flat out deny list, right? Don't let this stuff go. Users love this. Anybody have a spouse? All right, there's one married person in the whole room. How does your spouse feel? My spouse gets really mad when she goes on the internet and wants to connect to, when she's at home and she wants to connect to Concur, because they still make her do it the bad old way. It goes from our house to the VPN concentrator then it goes to Concur, then it comes back, and she complains to me because it's my job to fix all the things that are wrong with the internet. And it's like, why is Concur so slow? And I'm like, well, dump your VPN. It's like, wow, Concur just got really fast. But now I can't see any of my stuff at work. I'm like, yeah, I know. Life's full of hard choices, sorry. So what this says is for all your users at a site, it's the same problem, right? But they don't have to dump their VPN, right? They can say some traffic still goes over, site-to-site traffic still goes over a Silver Peak tunnel to another Silver Peak, all that goodness that comes with that. But if you want to go to the internet, here's your choices, right? Trusted apps, go straight there. Untrusted apps, pass them through a firewall. In between, maybe use something like a cloud firewall or a service chain to a local firewall. It'd be great if you get rid of those local firewalls. They're a pain in the ass. Why do you want to pay for and maintain a firewall at every site? You know, but if you still have them and you're using them, we play nice with them. There's another thing that I want to drive on this slide a little bit. So this is the cloud intelligence, right? So you think about, you know, this slide doesn't drive the point home very well. But every day, our orchestrator gets an update from what we call the cloud portal, from basically the mothership, that says, here's all the stuff that you might want to know. It's not quite like a firewall rules update, but it's similar, right? It's this automated new policy comes down from on high saying, look out for this, or here's a new set of app, like the best example is Office 365. Microsoft opens up a new POP, and now all of a sudden your user's email fails. Why? Because the POP that Microsoft directs them to isn't on your permit list. So that traffic just gets dropped. Well, we're updating the definition of what is Microsoft Office 365 traffic every single day in real time. We're learning from Microsoft. We're giving that to you. Automatically, automated, no human intervention required, just works. Multiply that by tens of thousands of apps. It's not just Microsoft Office anymore now. It's not Office 365. Think about all the same SaaS providers have the same problem. They open up a new POP, doesn't work until somebody goes in and modifies an ACL. We've beaten that problem for you for free. What else? Questions, comments? You guys are all hungry for lunch. We talked about this some before, but here's a picture on it. So we talk about channel bonding. What's going on here in this picture? Somebody's making a WebEx call from one site to another site. The link is wonky. Sometimes internet number 1 loses packets. Sometimes internet number 2 loses packets. What happens overall? Ooh. The overlay stays solid. So you hear this concept of the Internet 1 and Internet 2 are underlays. And you know, people are really reluctant. We try to sell them on the idea that you don't need MPLS. Stop paying all that money for MPLS. Just get 2 internet circuits and call it a day. And people in the room are smirking. They're like, no one will do that, right? Yeah, they'll do it when they see that it works like this. Save them a lot of money. And so the generic term that I'm going to use and that you'll hear Silver Peak people use is path conditioning, path conditioning, path conditioning. Path conditioning is this whole set of stuff we do. It's sending parity. It's bonding 2 tunnels together. It's correcting out-of-order packets. Anything that goes into a Silver Peak tunnel, you know, we think IPsec, right? Okay, great. We can send stuff over the internet and it remains private. It's in an IPsec tunnel. No man in the middle or woman in the middle attack can steal those packets because they're encrypted, right? But it's more than that. Silver Peak tunnels are also protected from loss latency and jitter using all these path conditioning techniques. Who can remind me what the path conditioning techniques are? Just give me one, please. I'm begging. Okay. Out of order packet correction. Loss correction, right? Parity. You're not paying attention either.
Forward error correction.
Forward error correction. There we go. Bingo.
I had a question on that one, your last slide.
Yeah, sure. Going back.
1 and 2, those are obviously 2 different providers, right?
Don't have to be, but it's better if they are because then you get diversity.
Okay, well then you answered my second question. What if a company is somewhere out and they only have 1 provider? Then they could do 2 circuits or 2 internet connections from the same provider.
You can do 2 circuits from the same provider. The problem is, you know, when the light-seeking backhoe wipes out their fiber connection, then you're hard down. If you can get diversity, like even if one of these fails, right? If this guy turns completely solid, 0 packets passing, we'll work with the second guy. Now you're not gonna have the benefit of 2 circuits to help you smooth out the loss latency and jitter on this guy, but it'll still work, right? It keeps working.
Issue all the way through, it's gonna affect both circuits
Yeah.
usually.
How do you do 2 circuits from the same provider? If you would think if one went down, they would both go down.
Right, that's the risk.
That's the problem.
That's why it's better to do diversity. If you can't get diversity, though, this still helps, because think about not the hard down condition, but just the impaired, loss latency and jitter go up.
You do it over one.
Yeah, well, okay, and you're making another good point. Let's say you only have one internet, right? You got a single circuit.
Yeah.
We still do all those techniques. If packets get out of order, less likely on a single circuit, but it can happen. We'll correct the out of order. We'll inject parity and data on the same circuit, on just one circuit, so that, now you have to lose a bigger combination of packets. Again, better when it's 2, because a lot of times when one circuit goes down, you're gonna lose 5 seconds of packets, or 3 seconds, or 300 milliseconds of consecutive. That's hard to recover from without a second circuit. But if you just have random packet loss on a single circuit, we're good.
So like when there's multiple circuits, the great thing what the system will do is because the system is monitoring the underlying conditions of each link, it'll actually put the data packets on the best performing link and the parity packets on the other link, right? So that's another benefit for having multiple. Now, if one goes down, you only have one circuit, then like Joe said, it'll put all the parity packets and everything onto that first circuit, and you'll still get the benefits. The trade-off is now you've got that overhead, right, going on there. So, yeah. So it's great. So you can actually have, if you have 2 circuits, even as the conditions change, right, the silver or the EdgeConnect product monitors it in real time. So you could have a data packet go on this guy, right, and then a parity packet on this guy, but then the conditions reverse. They'll actually reverse it as well, right, with it, right? So it's always trying to put the data packet on the best path possible, but then always giving that redundant packet coming the other end, right? So.
Yeah, good point. Everything about this is dynamic. We're like old school engineers. We tend to think internet 1's the primary and internet 2's the backup, and we put data on one. No way. It rolls automatically with no human intervention.
No primary or secondary.
Exactly.
They're using it.
Is anybody else doing that?
They're trying. They're doing better or worse. I mean, this is our differentiator, right? This is what kills this and WAN optimization. We do better than anybody. And it's just because we've been in the WAN op business for so long that, we've had the time to engineer it. More on this, but I think you guys are now grasping the point. When we lose a packet, we can use parity to correct it. Might be on one circuit, might be on 2 circuits, could be on whatever circuits you all have available. It's dynamic. We send more or less parity based on conditions. To your point, primary and backup can switch. It all works. Out of order packets is really important if you're doing the scenario where we're sending data down both, because the networks have different speeds and one gets congested and the other doesn't, and all of a sudden your packets arrive in the wrong order. We'll wait. We've got a buffer time where we go, okay, don't send an out of order packet or don't tell TCP things are screwed up for a certain amount of time, and then we fix it up and present it back to the application in order. God, I love this slide. So let me go through it one by one. This is a phone call now, right? You're making a voice call. You guys know what a MOS score is? Does a MOS mean opinion, MOS score mean anything to you? Good, okay. So when you have one circuit, this is why you don't want to put phone calls on the internet. This is why people scream at us when we tell them dump your MPLS. You get this much packet loss. You get like 1% packet loss and your voice quality goes to shit. So people don't want to do that. They've been yelled at, they've been burned. They say, I don't want to do it. I don't blame them. There's some selling and some teaching to do to get them to do this. With just one internet circuit, but all the path conditioning stuff we just talked about, we're good. We're good up to like 6-7% packet loss on one circuit, single circuit, right? But wait, what would you pay? Don't answer yet. You also get 2 circuits, right? You give me 2 circuits On both circuits, right? Circuit A and circuit B, you get up to about 9 or 10% loss on both before your voice quality goes to shit. Right? Very cool. And then this last one is a little bit, oh, they got rid of it. It's so gratuitous we took it off. We said you can have a lot of loss on one and no loss on the other. And the only point that's making is as long as one good circuit survives, your traffic will get through. We'll pick it. We'll use it. Questions on this? Does this make sense?
When you do that dynamic switching from circuit to circuit, how does that transfer rate? How quick is that? I mean, is it noticeable? Is it going to be, we drop for a millisecond and come back up?
It's not dropping, right? We're transmitting packets all the time. We're just like going circuit A, circuit B, data, 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 data. Circuit A gets crappy data, boop, circuit B, data, 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 data. So you don't hear it. I mean, we've even done the torture test labs where you just yank the circuit, right? Well, the circuit's going data, 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 poof, you know, and on a voice call, you won't hear it. The second circuit picks up like that. I hate to, you know, talk about, people get a vision, a carrier vision in their mind when you talk about, you know, sub-second failover or something, but it really is like that, right? We can super dynamically switch back and forth between circuit failure.
Yeah, to that point, I think also your question was how fast does the system react, right? So the point is even if you have a link failure, you've already got packets in flight, right? And so that's why when, like we were talking about how parity packets are already being injected onto the other link, that is what saves the call. Because you're right, there's a point where if a link goes down, the system has to detect it and then switch up what it's doing, right? In engineers called hysteresis, right? The time between the detected action, right, and then when the resolution.
I didn't want to bring up that term because I might confuse people if I said it, so I'm glad you did.
So, but what saves it is like Joe was showing, like, especially for real-time apps, because the system is already putting parity packets in flight, right? That's what saves the connection. So when the connection breaks, those packets are already in flight, right? And the Silverpeak on the other end can keep that call up while the system's detecting and moving over, right? Because you're right, there's several, you know, 1,000 milliseconds when when the Silverpeak's like, ooh, this path is no longer good. I got to put everything onto here now. But it's when the parity packets that are already applied. Yeah. So there's a mode where you can say no parity packets, right? And if that happens, you'll lose data.
Right.
You'll lose data.
So parity puts the data back together when you do the switch.
Right.
And you can rebuild from parity only, like when you go data, 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 parity, parity, parity. Guess what? If you get all your parity packets, you can put all your data packets back together. When, you know, when Humpty Dumpty falls,
Like the old technology of hard drives, right? The parity
exactly,
package.
same concept.
It's rate for network packets.
Okay, yeah, good. So now you got me started. Now we're going to go into an analogy. How are we doing on time? Am I going too long? Do we have 5 more minutes? Analogy time, right? So yeah, you hit the parity analogy is certainly like to disk, right? When your disk fails, you don't care. You get your data back. Everyone's happy. You know, you replace the disk and then life goes on seamlessly. The other analogy to make is virtual machines, right? Think about what VM does for you. You take hardware and you abstract it away and you go, what do I want my virtual machine to look like? I want it to have this much memory and this much processing power, and I don't care where it lives. I can move it here or here or here or here, right? It's movable. And I don't really care what the underlying hardware is either. I've abstracted that away by using a hypervisor, right? So this is the same thing. We've taken your network and abstracted it. We don't really care. One internet, one satellite, one LTE, one MPLS, whatever you got, we don't care. You use an overlay to say, what do I want my virtual network, my software-defined network to look like, right? And you can have lots of different ones. So this is another really cool thing to keep in mind. Like you might think, oh, well, if I say only send data down the best quality path and parity down the second best quality path, my second best quality path will never get full. Yes and no, because remember, that's only one overlay. If you define another overlay that says, use all the bandwidth you can eat, guess what? That fills up the second one real nice. The other thing is we're watching for congestion and dynamically adapting and loss and latency. So, you know, that noisy neighbor problem. Let's say some application that you're saying, yeah, just load balance across all paths fills one up. Well, the impact of that will be that you'll have increased latency and maybe increased loss. Well, we'll react to that. We'll go, we don't know why. It could be the carrier. It could be our own other application sending a shit ton of data and clogging up that circuit. We don't care what the reason is. We just go, that circuit's in trouble, adapt, pick a different circuit. So you're going to use, by having different applications and different bonding policies, you're going to use all your bandwidth. It tends to balance out really, really well. On the phone, comments, questions?
Oh, you're good. Thank you.
Okay, good. I'm going to give this one a real light touch because people already sort of understand what zero-touch provisioning is. But the concept here is if you take a device out of the box, you plug it into the internet, and you've got DHCP, you will find it. It will show up in your orchestrator. You can configure it. There's no truck roll. There's no, plugging in a thumb drive. There's no staging shit at one location and then mailing it out to everybody. You just drop ship it to where it needs to go, plug it into power. If you can do power and internet, and your ISP is, DHCP you an address, you're in business. There's a lot of security that has to happen to make that viable, right? And that's what this slide is all about. Like, no, it doesn't just plug in and get on your network. It plugs in and gets on your orchestrator. And you'll see this in the lab. Your orchestrator will see it, but they're not going to let it do anything until someone validates it, right? And this whole process has been built to be resistant or even impervious to like somebody plugging in a rogue device or somebody stealing one of your devices and plugging it in somewhere else. So your network remains secure even though you're taking advantage of the zero-touch features. And this, again, in large deployments, we love large deployments. If you're deploying 10 devices and some guy's got to pre-stage them, oh well, he'll just waste the 10 hours it takes to do that and get over it. When you're doing 1,000 devices, this is an issue, right? This hurts. One by one staging them and installing them. So the ability to do it automatically and remotely becomes super valuable.
So in conjunction with ClearPass, you have colorless ports or whatever, and I can define ports to say, I'm rolling out Silver Peak. If I plug it in, it'll automatically verify it then? Is that something that is now or can happen in the future?
Right, so 2 things. What happens now, this zero-touch provisioning won't interact with ClearPass yet, but you put your finger on something that is absolutely where we want to go. The other thing is behind this, right? So on the local area, the LAN side of the network, you bet. If someone is zero-touch provisioned a Silver Peak, and you've got site-to-site connections between all your Silver Peak networks going on, and then you plug in any kind of a Aruba device, a switch or an access point, all those things will now suddenly go, bam, I'm alive, and I can see Central, or I can see my controller, and all that good stuff happens. And yes, absolutely, we're working towards, I don't know remember that business intent overlay slide where I waved my hand over, this is not the network, this is a network. Right now, we're pretty much application focused, right? We say choose an application, groups of applications get the same treatment, they go in the same overlay. In the future, we're going to have groups of identities, right? You'll be able to go right down to the user, the authenticated user level and decide what overlay particular users go into. So that'll be fun and powerful when it comes out. So stay tuned. All right, this is hype, so I'm going to go through these quick, and then you guys can get to the lab because I think I'm a few minutes over. But basically, here's an example using something we all understand, Office 365. Okay, guess what? All 1,000 sites now need to support Office 365. And this is going to be our most important app, right? We're going to put it in an important overlay, a high priority overlay. Think about what you'd do if you had 1,000 ISRs. Some lucky guy would go to all 1,000 locations, schedule a downtime window, right? I need a change window to do this because I'm going to be messing with the device, and I might need a reboot, and I might have to upgrade software, and now I'm going to enter the same commands over and over and over again. And my mind is going to be numb, and you've got a CCIE skill level guy doing secretarial work, right? Doing just admin type stuff in. Because if something breaks, you got to know how to fix it. So it's not just typing it in. It's also like verifying that it works. And this guy's going like, why am I working for this company? Can I quit and work somewhere else and do something fun? I mean, right? And so just spitball. Say it takes 2 hours per site to start the downtime window, notify everybody, notify NetOps, make the changes, verify the changes, do a couple of tests, bring it back up. That's 2 hours, just a guess, right? You multiply that times 1,000 sites, and you're screwed. It's going to take you months to do this, right? And it's brittle. You make any mistakes, not good. If next month it's not Office 365, it's Workday, guess what? You get the same problem. So people say no, right? Engineers say no because they're like, I don't want to do this. And not only do I not want to do this, it's like I want to wait as long as possible and maybe batch 3 or 4 of these kinds of changes together. I don't know how, I don't, maybe anybody on the phone, have you had experience like working with the NetOps people who are like the wizards of no? Say, like, can't do it, not possible, have to wait, let's schedule it, and things wind up taking, months and quarters and years. You're not playing nice with me. You don't want to talk to me. My feelings are hurt. Okay, we'll just go to the next slide.
No, we
Here's
called
the,
them
here's the SD-WAN way of doing it.
we
Sorry,
called
go
them
ahead.
sleep stack people. I was just going to add to your vision.
Right, so here's the Silver Peak way of doing things. You say, okay, we're going to create a new overlay. We're going to put our Office 365 traffic into it. We're going to define an ACL that matches this. We're going to not the network, a network for 365, whatever features we need of that network. We got them, and look at this, 1,000 locations. You did them in 1 minute, 2 minutes. It's one change on the orchestrator. It's push it to all your sites. You don't need downtime because it doesn't screw up the system, and you don't have to reboot. People at the beginning will still schedule like a change window until they get used to it and go, you don't need a change window. You can just change it, right? It's the same everywhere because you've done it via policy. It's not subject to snowflakes. It's not subject to manual error. The orchestrator owns this config, right? The orchestrator does it for you. By the way, now Office 365, you haven't said a very long, complicated ACL with IP addresses and domain names. You just said application Office 365. We keep track of what does Office 365 mean because that's dynamic. That changes when Microsoft changes. Okay, good. I'm done talking. Thanks for your attention. Sorry to be such a jokester. We have a new lab to do. So we got modules 3 and 4 that will take you through the all business intent overlay stuff that we discussed that you're very excited about. And it'll also take us through the zero-touch provisioning, which is really, really easy. You'll be delighted about how easy it is to bring up a new site. We are here to address your questions, your concerns on the phone. Unmute yourself and speak up. We love you. We want to hear from you.
So I was just going to show 2 resources really quick that you can utilize if somebody does need to utilize our API capabilities, our REST API capabilities. If they want to use something like Python or whatever to access those. So the first thing would be if you look at your orchestrator should show it as well on your lab here. If you go to the support tab, you can see under user documentation an entry there for REST APIs. And essentially it will take you to a page and show you all the APIs, right, that are available to make calls to the orchestrator and either for configuration, reporting, all of those different types of APIs that you could use to affect your system if you need to. And so essentially the orchestrator and the appliances communicate over REST API. So Silver Peak has exposed those for customers who find a need for them. We have tried to include as much into the UI as possible. However, there are times when customers they have a particular use case where an API is valuable. So one of the most used instances that I've seen is when, for example, we try through the UI to give as many comprehensive reports as we can. However, sometimes customers want to see things presented in a different way, or they want a specific piece of information maybe that's not getting displayed in our reports. So all that information is available, right? And so they can pull the orchestrator via an API, collect that data, and then basically use that data however they want or display it however they want. So for example here, if you go to that REST API page in the orchestrator, it will tell you what all is available, right? And then you can just expand on each one, and it will show you the REST API call here, right? And it will show you what is contained in that call, what information you will get, right? And it will show you how to make the call, what parameters you need, and then how it will be returned for you, right? And so essentially, and then it'll say you can try it out, right? So you can actually click on it and it will pull whatever appliance that you want or whatever the parameters are, and it will actually model it for you to show you what information you'll get, and it's all in JSON responses, and then you can do whatever you want with that data. The second resource that I'd like to show you as well is Silver Peak on GitHub does have an SDK page, right? That will show you different examples as far as Python scripts. We have ones that are already pre-configured, right? Ones that have already been used. Others get added as people need them and as they find different situations. But if you go to this particular site here, github.com, right, SP open source, Edge Connect Python, this can help you very much get started, right, on your journey of, like, if you want to use Python to call APIs, you can just essentially come in here and you can see all the different scripts, right, that'll come in. And so, for example, just the login one will be the most important one at first because you have to log into the orchestrator and get a key that essentially you use to pass in all of your other API calls. And so this is a great script here, right, that you would probably look at doing first, right? Again, it's in Python, pretty straightforward. You can see there's not a ton of code that's needed. That's a great thing about Python. But the SE that maintains this SDK, right, does a great job of descriptions, right, and letting you know what each snippet of code does. So if you have a dev team or somebody on your team who likes to do a lot of Python scripting, use that Python scripting to call and call APIs, then essentially these are two resources for you that you'll find valuable. All right. Any questions about that before we move on? All right. Can everybody hear me? Make sure everybody can hear me on can those of you on the WebEx, can you guys hear me okay?
We can hear you.
Yep.
Okay, great, perfect. All right, so we'll go ahead and get started back on. I'm sorry?
What did you learn?
Yes, yes. So you guys just did lab modules 3 and 4, where you did some configuration of business intent overlays, as well as you walked through the zero-touch provisioning process on actually deploying an appliance. Does anybody have any questions about that, or something interesting that they learned, or anything that they would like to talk about on that section? Any questions, observations?
Well, one of the observations that I found pretty useful was watching the configurations actually be applied to the application. So what happens is right above where it says in green healthy and 1, the number 1 in amber, there'll be like a little link temporarily that'll show your configurations being pushed out to the devices. And then if you click on that, you'll see what's happening. And just from being CLI, I like seeing that.
Gotcha. Okay. Yeah, where it's actually kind of logging the process as it's happening.
Right. Because one thing we have to do sometimes is go through the logs.
Right.
And just a neat little feature.
Yeah. Well, great. Good. Yeah. Like I said, even though we try to make the process as automated as possible, we also try to give as much information as we can. So if something does go wrong, you can go right and look and see, okay, what was happening, and hopefully help you find the error quicker. So good. I'm glad you found that helpful. Anybody else? All right. So this next section, what we're going to talk about are some of the security features, right, that the Silver Peak has. Security, obviously, on the WAN is a big topic, right? It's a big concern for companies. And now you have really the security space is seeing a lot of transformation along with the WAN, right? So with now applications moving to the cloud, right? And now perimeters no longer being, just in your data center or just at the site. We've seen things evolve, such as with the SASE architecture, right? Another way that you can implement security within your company versus just what was, typically done, where you either just place physical firewalls at each site or physical firewalls at a centralized location and make that traffic, force that traffic to that central location, right? And so now we have users that are at home, we have users that are mobile, and we have applications that are no longer in facilities that we even control, right? They're in AWS and Azure, and so security has to evolve with that, right? And so with that, one thing I love about the Silver Peak product is that we will never tell a customer how to build their network, right? We have customers that are still, right, they still have firewalls at each location, right, of their sites, because maybe they just bought 500 firewalls a year ago, right? They want to implement SD-WAN. What they're not going to want to do is then toss out 500 firewalls that they just bought a year ago. Maybe they'll look at tossing them out in 5 or 7 years, right, when they go end of life or when it's time for a refresh. So we'll never tell anybody how to build their network. We work in any situation. However, we can talk about possibilities of what you can do. And we're talking about transformation and transitioning from a current model, right, to what your network might look like here in 3 to 5 years. So, and what I mean by that is a lot of times what I'll tell customers when they're buying the Silver Peak product and implementing it, you're really buying a foundation for the future. So for example, this customer that they just bought 500 firewalls and they bought Silver Peak and they're implementing Silver Peak, they'll want to keep those firewalls, but then maybe over the next 3 to 5 years, they can transfer functionality from those firewalls to either the Silver Peak or into a SASE architecture or something like that. So when it comes to basically end of life, those firewalls, they can do so very easily. So with that in mind, we've incorporated a lot of security features within the Silver Peak platform that a customer can take advantage of if they need to. Okay, and so again, there's a lot of approaches, different approaches to security, but you absolutely have the ability within the Silver Peak, right, to do things like micro segmentation, where you can provide security on an application basis, right? You can still do it kind of some of the old ways by IP, by ports, things like that, but really it's by applications is what we think of. And that carries, right, across the entire fabric. That's what we want. We want to be able to implement security, again, in an automated fashion, not by device, right? And so anyway, so we have a lot of the standard things. We can support micro-segmentation. We secure our traffic, right, between our sites, IPsec tunnels, 256-bit encryption, right? We offer stateful firewall capabilities today. We are not a next generation, what you would consider a next generation firewall, offering things like unified threat management or things like, IPS, IDS. However, those are things that we are developing since our acquisition with Aruba. We have on our roadmap where we're going to be implementing or tying in with ClearPass as well as their current UTM engine. So within the next probably 3 to 6 months, we're going to start seeing we're already seeing the development. It's been released in beta code, but as far as that code now being made available to customers and then maturing, we'll see that over the next 3 to 6 months. And then, of course, service chaining, right? Doesn't matter to us whether you have a firewall on site, whether you have cloud security, or whether you're doing a cloud security provider like Zscaler or Netscope or Palo Alto Prisma. We'll tie in with any of those. Okay. And again, end-to-end segmentation. So we have zone-based firewall capabilities, right? And those zones, when you apply, we'll show you the template that we use to apply our security policies on the zone-based firewall. Those ideally, right, is what you're applying to your environment as a whole, right, to the entire SD-WAN fabric, to the entire, all of your sites across your company, right? We're trying to avoid the snowflakes, right, where you're going in one by one and configuring things and you might miss a rule. You're creating an overall policy and then expanding it over. And again, you can segment that, those firewall policies, right, by applications such as like, POS systems or an ERP system, or you can do things like guest Wi-Fi, right? So anybody who comes in on your, any location comes in on the guest Wi-Fi network, this particular application or this particular zone is segmented from all of the others, right? So again, as you can see here on this particular screen, for your POS application, it is kept separate from all other applications all the way across the fabric. So from the branch to the data center, and then you even keep the same thing with your other applications such as your ERP systems, HVAC. Wi-Fi goes directly to the internet. It cannot reach any of these other zones. And it can only go to the internet, right? It can't go to inside of your IPsec tunnels or anything like that, right? So very easy to create segmentation within the Silver Peak platform. Again, it all goes back to like what Joe talked about in the last session, which is your business intent overlays. You do all of this within your business intent overlays, how you want these particular applications to be treated.
Can I jump in now?
Absolutely.
I'm very passionate about the second item up there, HVAC.
HVAC.
Why am I passionate about that?
I
How did the target breach happen? Remember the
Yeah,
10 years ago?
HVAC.
They got in through the HVAC. That was the trick. So why on the earth was HVAC talking to your servers? Doesn't need to.
Well, sure
It needs to know
does.
what's the temperature, and that's it. They should talk to each other and nothing else. And then the other reason I'm passionate about this is a lot of security folks are focused on clients. Right? You just put a client on your laptop and on your phone, and you're good. That'll stop all. Well, you can't put a client on the HVAC. It won't run. It doesn't work that way. So if you really want to get serious about, policy is the same thing. It's super important to keep it segregated, and it also probably won't run the client that everyone wants to sell you. So those two things alone are reason enough to have a zone-based firewall, a security device of some kind that doesn't rely on a client. Right? Mm-hmm. So people overlook that a lot, and it also is end-to-end. It's from LAN across your WAN back to the far side line. It doesn't matter where you're starting from or where you're finishing. HVAC talks to a very limited list of approved other stuff, right? Guest Wi-Fi, it talks to nothing. It goes to the internet or it dies. That's it. We're not letting guest Wi-Fi come snooping around. This is like security, like reduce your attack surface 101 kind of stuff, but people neglect it or people don't value the features that enable it maybe. So that's off my soapbox, but I like the slide.
All right, thank you. So one of the things that Silver Peak developed, we had one of our product managers has worked in the security industry for a long, long time. And she actually used to work for Palo Alto. And she had suggested trying to create a matrix like this rather than the rule sets, right, that are just one rule, the next rule, the next rule, the next rule. And they told her no. So she's never been able to develop this. She came to Silver Peak. She's no longer with Silver Peak anymore, but she was with Silver Peak for several years. One of the things when we implemented our zone-based firewall, she said, I would like to do this. And so Silver Peak said, do it. And I absolutely love this, right? So because it's very easy to see what your rule sets are. So for example, if you're on guest Wi-Fi, it shows you basically all your zones on the left side are the zone that traffic would originate from and what zone they're trying to go to. So you could say, okay, guest Wi-Fi, right? If I need to go to another zone called guest Wi-Fi, I can do that. But if I want to go from guest Wi-Fi to corporate branch, deny all, right? It's very easy to see what is happening, right, with your rule sets. It's a matrix view, right? It's a picture versus seeing rules. Now you can, if we switch to table view, if we were in the Orchestrator, And actually, I could probably show you here really quick, but if you go to table view, you can view all these rules just like we've always done and how they are viewed today in next generation firewalls. But the visual policy matrix makes it very easy. And actually, I'll show it to you here really quick. I believe I can still get into the SD-WAN here. Makes it extremely easy to get there. Let's see here, see if it'll still let me. Sorry, gotta log in. All right, well, you'll see it when you start working with it anyway. I was hoping to show you really quick, but you can actually, if you need to dive into all the specific rules, right, say for a corporate internet branch to default, all you'd have to do is come into this box and click it, and then it will list the rules, right, that you can choose from to add into that. So it's very, very easy, right? Most of the time, right, when you're looking at traffic going in between zones, like for example, if we needed business critical, right, to go to the corporate WAN, right, you could say, oh, well, why isn't this traffic working? Oh, deny all, right? You know, so that's typically what things fall into. So we've made it very easy. You can choose between the matrix view or the regular table view, but I think the matrix view just makes things a lot easier to understand what's going on, right? And so basically that's how you configure it. That's how you can look and see what you've got, what you have configured between the zones, what traffic you're going to be allowing. So again, just another little. I say it's a little thing, but it took a lot of development to do this. But it is something that we've tried to make people's jobs easier, right, than what they've been in the past. So we'll switch to a little bit about QoS, right, ensuring priority for business apps. So essentially, this is a picture of the shaper, right, that the Silver Peak uses essentially. So if it starts seeing congestion, right, on its WAN side links, these are the QoS policies, right, that will come into effect to make sure that your priority applications are getting treated properly. And it's very simple. We actually configure this for you right out of the box. It's based on our experience over the last several years working with, thousands of customers. And so right out of the box, to be honest with you, 99% of the time, this is going to work for your network, right? Some other customers have, some different requirements that they need, and they can come in and they can come into the shaper and tweak whatever they want. But essentially, we just give a priority to your traffic. 1 is the best, 10 is the worst. So if you've got, voice and video are your most important, give that a priority of 1. If, YouTube traffic's your least priority, give it a 10, right? I mean, it's very easy to configure these traffic classes. We do them, again, right? The shaper kind of comes out of the box for you based on what we've seen. You can tweak it as you need, but most of the time, our customers in the business intent overlays will just say, this is a 1, this is a 2, a 3, a 4, or whatever. And then from there, 99.9% of the time, they're rolling. WAN optimization. So the third thing, we've talked about it a little bit earlier, the capability that Silver Peak started as a WAN optimization company, and we've kept those capabilities within our product. And so this is essentially when you need to move data across long distances. So, right, the more distance there is between endpoints, the latency of traffic, right, the time it takes for traffic to get there increases, right? And so latency and throughput have an inverse relationship. So as latency increases, throughput will decrease. So that's why you have customers that are like, hey, I'm in Alaska, I'm trying to reach, a data center in Florida, and my application performance is terrible, right? And that's the reason why, is because it has to go that long distance. And so you can basically enable through the business, and remember, a business intent overlay, right? Basically is how do you treat this application or group of applications? You can, through your business intent overlay, apply WAN optimization, right, to the applications that need it. So no longer is it an all or nothing proposal like it used to be for those of you who have worked with WAN optimization in the past, right? It's not an all or nothing thing. Now you can do it by application, and you can do it on a per site basis as well, right? So what it entails essentially is TCP acceleration. So that's, for those of you who have been with WAN optimization before, it's the TCP protocol that basically all network protocols or network traffic works with in order to move data. It doesn't work well over long distances. So we will accelerate that TCP connection by proxying it locally. And then once we're actually putting data on the wire, we will compress it and deduplicate it as well. So we don't really see too much of a need for deduplication and compression anymore, simply because that was really made when MPLS pipes were being used primarily, right? They're small. And so now with customers being able to get internet links, I can get a gig internet link for $60 a month. All of a sudden, they don't really have constrained bandwidth issues anymore, more than distance. So, but anyway, the feature is there for customers who need it when they want it. And again, this just kind of shows you a little bit about how TCP works. And this slide here, I've always had trouble explaining because I'm really not sure what they were trying to do with it, like with the buckets of water and stuff. But the point to take away with it is that you only need to apply it where you need it, right? So if you only have 2 sites that need WAN optimization, you can just enable the feature, right, on those 2 appliances if necessary, right? So you don't have to buy big boxes anymore, put them in, it's just for those particular applications, so.
Yeah, I mean, just for context on this, on why this is important, is old WAN op systems where you bought a box, it was really expensive, and you bought a perpetual license and you optimized everything. Like whatever went through that box, you just attempted to optimize it. So then it was kind of somebody else's job. Somewhere else in the network, you had to go, all right, well, I'm going to policy route traffic that I want optimized or that will effectively get optimized. I'll use a policy to send those things to the optimizer, and everything else I'll send around the optimizer. Because you didn't want, like, if something's already compressed or it won't optimize well, you're wasting money by sending it through the optimizer. Well, we've sort of said, nah, send everything through the silver peak, but then you only optimize per overlay. Like you remember we talked about overlays before. There's groups of traffic that you want treated the same. Some groups of your traffic will respond well to optimization. So for those, you turn it on. For the others, you don't. And so in that way, you can be really selective and use your optimization dollars well. You can only apply it to stuff where it's going to work and or where the data is valuable enough that you care to do it. All the bottles on the left are trying to say if you got 5 sites, you got to buy 5 optimizers and then 5 times that capacity in the middle to support it. And if you on the right, you're saying, but that doesn't work. I mean, it doesn't work for me. I don't want a pint at every location. I want a few ounces at some and none at another and a half a gallon at the third one. That's what you can do, right? You just be selective and strategic about where you optimize.
All right. All righty. So that was a short overview. And now we're just letting you dive into the labs, right, on the zone-based firewall and configuring WAN op on a particular application. So in your lab modules, go ahead and go through modules 5, 6, stop after 7. And and then after that, really, I think there's just product overview after that. These might be the last lab modules that you'll be doing. So
just to help you understand what to expect for the rest of the day, we're going to do 3 labs, we're going to have a quick product overview, and then we're going to ask everybody to earn their certification. You are now ready to take a test and become SD-WAN certified.
Yeah.
And there's also a survey that helps us do better as delivering this content. So that's really how we're going to spend the rest of our time. Probably, what do you think, 45 minutes on this lab, 30, 45 minutes?
I would say 30 on this one. It's
Right,
pretty.
30 minutes, we'll extend that if you need it. We'll do this last section, and then kind of the wrap up is the, get your feedback, take the 10-question exam that I know you will pass. None of this self-doubt. Come on. And then we'll call it a day.
All right. Yeah. So again, let us know if you guys have any questions or have any problems with the lab. We're here, and yeah, we'll let everyone get started. Yeah, did you see the on the orchestrator where I show where you can go to support and see the REST API information on the page there?
Yes, actually. Yes,
Okay.
awesome. I really appreciate that. And when we're over, I'm going to ask you another quick question when the training's done. Oh, but yeah, awesome.
Okay.
Thank you.
All right. And did you get the GitHub page as well?
Yep, sure did.
Okay.
Sure
Perfect.
did.
All
That's
right,
exactly
cool.
what I was looking for. All right.
All righty. All right. Well, I'm going to turn it over to Joe now. He's going to take this last section. You guys are almost done. So, and I don't think this section is very long either. So, all right. I'm turning it over to Joe.
All right, can you hear me now? Can you? I feel like I'm the Verizon guy. Can you hear me now? So, what did you learn? What worked? What didn't work?
I mean, I'm getting obviously the gist of it, but there's definitely some intuitive steps that if you're not familiar with it don't seem to be documented in the guide very well. So,
okay.
but you know, other than that, I'm figuring it out. I mean, I'm getting a feel for it for sure. So.
No, that's good. How did you feel about the capabilities of the zero touch specifically? Like the wizard sort of, first off, when there's something new on the network, it just appears, right? I mean, in real life, all that amounts to is power and a DHCP connection. In the lab, there was a little bit more to it, but did that seem like something your customers could manage? Or you could manage? All right.
Yeah, with a little, sure.
I think so. Sure.
And then, like, did you have any other surprises or hiccups? I'm always interested in that. Like the zone-based firewall, we had somebody.
Yeah, they had to go in and adjust the rule to allow FTP. I know we're coming out with that new, Alex is publishing the new deal, so I think some of these things will probably be hopefully addressed, things that we've heard throughout.
And did anybody get up to boost? Did anybody successfully boost a file transfer?
No.
Yeah,
Okay, who said yeah?
I did, Tony.
Okay, Tony. So explain that to the team. What was that like?
It was fairly straightforward. I just found the instructions there, but I found that once I did the boost, that file transfer from Evernote was much quicker. But the steps involved are exactly what's outlined in the guide for today. But I gotta say one thing. I want to echo what one of my teammates said there is that I think with practice, this will become more intuitive. The other thing that I'm really liking about it is not only how it picks up the end devices, but if you run into troubleshooting, that's where the learning part comes in. And to answer your question about is it something the customers can manage, again, I would say definitely. It's in the troubleshooting where you gain confidence.
Yeah, 100%. I agree with you on that. And so let's talk about practice. If today's lab is available to you on demand, so if you want to run it, get in touch with me or Jason, and we will set you up with an instance. And instead of trying to cram all this into 4 hours, you can have 4 days. And also, there's other labs, right? There's other opportunities, learning opportunities that, the same thing. There's a step-by-step guide, and then you can go off script a little bit and try to break things and test stuff out and see what really works and how, challenge your debugging skills and all that sort of good stuff. So that's out there. All our training for the moment is no cost. So take advantage now. We'll send you the training link, and you can register for on-demand or instructor-led or via WebEx, whatever suits you. And
Great.
I don't think it's going to be free forever. I think part of the HPE Aruba regime is going to start, require us to start charging for that stuff. So
Okay.
Sooner is better than later if you want to save money and have low hassle. Anybody else have any learnings or questions? Okay, so what we're going to go through now really quick is just a product overview. And the idea here is to help you understand either how to deploy or how to sell this, right? So it's here, and I was told not to stand here and wave at the screen because the white washes out and you can't really see what's going on. But it's all good? Well, what I'll tell you is that you get a lot of goodies in one package, right? I mean, you get all the features kind of up here on the WAN side. So we haven't even gone into like BGP routing, but we can interop with any BGP router that you need to, or OSPF router. You get the WAN op, you get the QoS, you get the business intent, you get secure internet breakout. All these goodies are in the basic package. They all work on any kind of circuit. We are bandwidth agnostic. Any LTE, satellite, broadband, MPLS, smoke signal, whatever people come up with to send bits, we'll take advantage of it. On the LAN side, you get a lot of stuff too. Remember, we're advocating this thin branch idea. So what's a thin branch? It's one device in your branch. It's an edge connect. And but to do that, like, there's some legitimate concerns. Well, who's going to be my DHCP server? The server peak can do that. Who's going to handle my LAN side routing? The Edge Connect can do that, right? Who's going to be my firewall? Edge Connect can do that. To be real clear, we don't really do the IPS IDS yet. We're working on that, but also you don't need it, right? You can use a cloud firewall, or you can backhaul stuff that needs inspection. So it's a simplification step to kind of remove the firewall from the branch as much as possible. Also notice that the orchestrator, the thing that you're interacting with right now, that it's just a VM that either runs on your hardware or on ours, it didn't cost anything. That's just free with the product. That's part of the service, right? So you don't have to buy an orchestrator. There's no concept of purchasing an orchestrator. Now, if you host it on your own hardware, it's free. If you want us to host it for you, which is actually kind of cool, that, we're going to charge you for the compute. We're going to run it somewhere in Amazon, and there's going to be an annual cost for us to run it and maintain it, but it really just offsets, it's what you pay for your own hardware anyhow. It's kind of a wash, whether you do it yourself or whether you have us do it for you. We like doing it for you because we're really experienced at it, and our DevOps guys who do that do it every day, and they do a great job of like maintaining backups and helping you keep it upgraded and all that kind of stuff, but it's your call. Our licenses, so the licensing model goes like this. How much WAN bandwidth do you need? Right? And here's our tiers. You can go, up to 20, up to 50, up to 100, up to 200, up to 500, 1 gig, 2 gig, and unlimited. Right? And so the crazy thing is you can buy any one of these bandwidth packages and put it on any appliance or virtual machine. Now, it would be stupid to put an unlimited license on a little tiny box that, the box can only do 500 meg, but you could. And vice versa actually makes a lot of sense. You can buy our biggest box and only license it for like 500 meg. You're like, why would you want to do that? Well, because you're going to grow. You've got headroom. But, while you only need 500 meg, you only pay for 500 meg. When you grow to a gig, you just pay the difference between 500 meg and 1 gig prorated over the remainder of your term, right? So I always tell people, start big on the hardware because that's a forklift. That's a pain in the ass to take it out and replace it. And start small on the software because it's real easy. It's a phone call and a PO and like a 2-day turnaround, and you've got your extra software bandwidth turned on. So every device needs a bandwidth license. If you get a 1 gig license, how much does that really mean? Like, what do you really get? Let's just presume the hardware supports it. All right, this isn't a good question. The point I'm driving at is it's 1 gig in and 1 gig out. That's bi-directional, right? Some of our competitors have an idea that a 1 gig license means 500 in and 500 out. So just be aware of that. Make sure you're comparing apples to apples. If you buy a virtual, right? Let's say, or not buy, say you want to run Edge Connect software on your own hardware, not on our appliance now, on your, on a hypervisor in your data center or in Amazon, right? We have a sizing guide that tells you how much compute and how much memory and how much IOPS to get to the various bandwidth levels. So you can very nicely balance and match the bandwidth license you buy with the hardware you rent from Amazon or the hardware you allocate from your own compute environment. Boost. So we talked a little bit about Boost before, and that concept of you only buy what you need and you can allocate it per device in whatever kind of 1 meg increments that you need to. And in fact, in the lab, you experienced this, right? You went in and you said, oh, put 10 meg of Boost on the new device that you configured. So now you see how that works. And when you buy Boost, you buy like a network-wide pool. Let's say you buy a gig for your whole network. And then you can put 10 meg here, 50 meg there, 100 meg in the data center, whatever makes sense for your traffic. So super flexible. You can allocate and you can reallocate. So let's say, you allocate your 1 gig and you look at your network a month later and you say, well, I'm using a lot over here, I'm maxed out, and I'm using none over there. Well, great, remove it from one device, put it on the other device. We don't charge you for that, you can do it yourself, super flexible. All our licenses come in 1, 2, 3, 4, 5-year terms. On paper, you don't get a break, like a 1-year license, a 5-year license costs 5 times the 1-year license. So people look at that and go, that's crazy. Why would I ever buy a 5-year license? I could just buy 1 year and pay every year. The real answer is you'll get a better deal on a 5-year one. It's just not published. So beat up your account rep. Tell them I'll do a 5-year term, but I want more discount. Any questions about this part, the sort of the tiered licensing and the boost and how we sell it all?
Seems like it would make sense for something like this to be, if the user didn't want to do the management themselves, then we would provide a support contract to look at this monthly, to look at those different allocations of wherever it's being allocated and do those adjustments for them. Because realistically, somebody may not go in and check on it every month. If it's working until they get a phone call, hey, something's slow over here, that's when they'll probably look into it. Right?
Yeah, well, it's 100%. Like, so first answer is yes, we support you. If you can sell that service, do it. We want you guys to do all the possible, add-ons, upsells, professional services, all that stuff is fair game and totally support that. The second thing is there are sharp tools, right? It tells you, I'll show you if you want, there's a screen that tells you, okay, how much boost have I been using at any moment in time and when have I been maxed out? So it's not hard to monitor. So, if you want to monetize that and do that on your customer's behalf and get them to pay you to do it, great. If they want to do it themselves, it's not that hard. So all those options are open. Other questions?
Do the devices come in the 20, 50, 100, 200, 500?
We're going there. You're a great straight man. Good question. I think it's the very next slide. Not yet, just bear with me for one more, it's the one after this. So remember that you can buy an appliance from us, and this makes a lot of sense when you're at a branch location that is a thin branch, right? You don't have a compute farm out there. You don't have an IT guy who can spin up a VM and manage a hypervisor and do all that stuff. So just ship a device out there, zero-touch provision it, you're good to go. In your data center or at your places where you do have a big compute farm and you'd rather not pay for our compute, great, use your own. We'll set you up with, then you pay nothing for the hardware and then you just subscribe to the software. You get a 1 gig license, we tell you how much compute you need to run that, and you're off to the races. Cloud native is really, really interesting. It's really important. Do you want your Amazon website to look like just another node on your network? If you want that, then you buy you do the same thing. It's still just a virtual license, but now you go to the Amazon Marketplace, you install it there. And we've even got a one-click install now where instead of having to size the machine and very carefully put all the right, all the right parameters that we were putting in earlier, it pops right up. Why would you want to do this, right? Why would you want to have a SD-WAN to the cloud? Somebody on the phone? Everyone in the room's falling asleep. I need you. Pick me up.
What was the question again?
One-touch provision?
Why would I want SD-WAN to the cloud?
The cloud, yeah. To Amazon or Azure or Google Cloud.
Update all your devices at once?
Yeah, kind of. I mean, that might come into it.
Technically, the cloud's part of your network, so wouldn't you want the same security and policies and all of that?
Yes. All the same security, all the same routing policy. Also, you can save some money. Are you using Direct Connect? Ask your customer, are you using, what is it, Direct Connect, or what does Azure call theirs?
Expressway.
Yeah. Direct Connect, Expressway. Those things cost a lot of money. Those are expensive. Why do you buy them? Because you don't want to go unprivate. You don't want to go over the public internet and have your data, right? What does the Silver Peak do for you, among other things? It encrypts all your data over the public internet, right? So you get a secure connection over an internet link that's a lot cheaper. You don't have to let the crooks at Amazon charge you for Direct Connect.
Or Azure. Amazon or Azure. Yeah.
Also, routing through Direct Connect is not impossible, but it's a backhaul model, right? Everything goes somewhere, and then it goes over a Direct Connect link. if you want to go straight to Amazon over the internet, you can avoid that whole backhaul to the internet. It's the same problem. Backhaul to direct connect to Azure or AWS.
Back to the typical, we'll call hub and spoke topology, right? Where all the branches are coming to core, then it's going out, the direct connect to the cloud. Versus if I'm in a branch office and I'm accessing an application that's in the cloud, why go to corporate, right?
No reason.
Go right to the cloud directly. Cut down latency, cut down, traffic at the core, all that stuff.
Plus, we'll do redundancy. If you're doing Amazon East and Amazon West, we'll treat them both like just a regular node on your network. All the sites can connect to them if they want. One fails, you can find services at the other one. So there's a lot of good reasons that you'll want to have cloud native. All right, now I'm coming up on your question. So that's where you can run it if you're doing, that's your sort of three choices: physical, virtual, cloud native. If you're doing physical, here's our platforms. And this is always out of date because we're always updating it. Like this is right. Is this right? Here are the two important roles. This is how much WAN bandwidth you can get. This is aggregate output on all of your interfaces. So if you got one interface, that's how fast you can make it. If you got two interfaces, 500 meg plus 500 meg means you need something that can do a gig. Pay attention to the redundancy. These ones, I'm sorry for everybody on the phone, I'm waving at the medium, the large, and the extra large have redundant power and SSD. So these are good for data centers when you really can't have hardware failure. These guys, not so much, although there's a new redundant power option coming for that guy, or already available? It's already available. Okay. The second column to pay attention to is how much boost you can do. So let's just take this guy. He's our workhorse, the extra small. This is what usually goes out to the hundreds of branches. He can do 500 meg, of which 50 meg can be boosted. Remember, we're talking about you don't have to boost all the traffic. You can be very selective. If you try to boost more than 50 meg, his processor is going to go and die. So those are the two things you need to pay attention to. You don't want to exceed either one. Total WAN output, of which can be boosted. What are the limits on the LAN side? Why aren't they on here? Because there aren't any. It's whatever the box will do. There's no licensing. There's no, if the box can do it, knock yourself out. I mean, and the bad side of that is you can't overdo it, right? So you need to pay a little bit of attention to how much stress you're putting on the box. But generally speaking, LAN side traffic is lickety split.
For the branch office, it's the ECXS is your bread and butter kind of thing. That goes out to the majority of the small ones.
This guy's the workhorse because he's got 4 interfaces, right? You can do 2 internet, you can do 1 or 2 LAN. This guy, he's just a little bit limited because only 3 interfaces. He's the size of like one of those Apple TV boxes. Yeah. And honestly, I mean, I like the box for a home user or for a really like a pop-up site, but it's for corporate network. You want to be, you want to have something a little bit beefier.
Is there are WAN and or LAN? So it's 4 total. So I could have my local area, then I could have 3 wide area networks.
Exactly.
I could have whatever mentor you 2 different ISPs or whatever.
You're correct.
And I would software define across all 3 of those. Okay, got it.
Everything's in Ethernet. We don't do nothing but Ethernet. So, we're hoping that your cable company or your MPLS provider is dropping off Ethernet. If they're not, you need help. Our friends at Aruba will be glad to provide the right goodies. What else is there to notice about this?
Taking Ethernet directly from the cable modem or the ISP or whatever in your scenario. Okay.
The big boys can do the SFPs, SFP plus. This guy is coming with a 25 gig. Now the box can't do 25 gig throughput, but we can have the 25 gig Ethernet interface if you need that kind of a handoff.
Okay.
Answer your questions about hardware? Yes. Prices. Prices aren't on here. Talk to your sales rep. But they're what you'd expect. The big ones are expensive. The small ones are cost effective for hundreds to thousands of branches. We talked about this before. We'll do a little bit more depth on Orchestrator as a service. Why would you want to run your own Orchestrator? Because it's free, because you have a competent staff that's good at spinning up a VM on a hypervisor and the care and feeding of it and backing it up and all that stuff. Why do you want it as a service?
We don't have to worry about all that stuff you just talked about.
You just pay us. We do it for you. And it's like accessible from anywhere in the world. This is the other sort of subtle point that people miss. Let's say you choose to run your own in your own data center on your own hypervisor VM, right? Great, you're saving money. You have competent people. They need something to do. Let's keep them busy. I can't get at it. TAC can't get at it, right? Because it's behind your firewall. So if you call and ask for help, we're going to go, all right, well, can you log into it and share your screen and give me control and, all that rigmarole. If you put it as a service, it's just on the public internet. It's just out there on Amazon. And if you say, Joe, here's your read-only credentials. Take a look and let me know what you see. I'm there, right? Or you can do the same thing for TAC. Or you can do the same thing like when you're at Starbucks. You don't have to goof around with VPN or whatever else you have to do to get past the firewall. You just go to the site, work on your stuff. We have Okta.
Separate than Central, correct? It's not
This is now separate from Central, but guess what?
Central eventually.
It's the same thing. So there's going to be hooks and connections between those.
Together. Okay.
Questions about Orchestrator as a service?
No.
This is so out of date, but we'll brag about all the good stuff we do in terms of customers and patents and 400 employees. Those were the good old days, huh? We have a really good TAC. Okay, so before I came to Aruba, I was doing 19 years at Cisco, some of which was in Cisco's TAC, which is also very good. But I'm just pleased with the amount of happy customers I get after making a TAC call. You know how that can be, right? People go like, I didn't get a call back, or they didn't understand me, or my problem didn't get resolved, or very little of that. And if you get any of it, call me, and I shake the tree and they deal. So, okay, that is it. We've reached the end of the death by PowerPoint. We're going to have an exam and a survey that you're all going to pass.
All right.
Even you're passing, Andrew. All right. And do we have the link for that? Is that?
Yeah, I think
it's on the next slide.
Yeah.
Exam, survey, and then we all want you to know where the learning management is. So if you want to take another class, also just hit me up privately. Like I make sure you get my email out there. It's on the invite already, I think. We can get you, like this lab that you're on right now is probably good until about 6 p.m.
Yeah.
Ish. They'll probably recycle it about 6 or 7 tonight, so you have a few more hours. And if you want your own instance for a week, all you got to do is register. I'll send you an invite code, and you're in.
I think Maria is also putting this link in the chat.
Thank you.
Thank you. I'll go there.
Okay, and the test and the questionnaire are all balled together at the SurveyMonkey. You just one link, and you get a twofer. So we're not going to let you take the survey without passing the test. And in all seriousness, if you have questions about the test questions, I'm happy to talk to you about them or explain them in a little bit more depth. But they're really, really, really 10 of them, and they're doable. And you get, I think you only need 7, right? And you get a certificate that you can put up on LinkedIn.
That's right.
The SurveyMonkey is the test and the.
Yeah, it's both the survey and the test. And yeah, this is all the details. Just training.silverpeak.com, and you're in. You can self-pace. You can register for a specific class. There's little bite-sized ones that are literally like 20 minutes. They're really, really quick little classes.
Yeah, so I'd encourage, especially the engineers, to not shy away from the advanced technical training, right? This isn't like going to get your CCIE, right, where it's like a year's worth of work, 2 years worth of work. Because essentially, right, we're not forgetting the things that we know as network engineers. It's all just being done under the hood for you by the Silver Peak Orchestrator, right? And so it's just learning not only what menus to go to and to click on, it actually goes under the hood and explains to you what the Silver Peak is doing, right? It's the same exact training that all the SEs go through, but you can essentially earn your expert certificate in 3 days, right? Doesn't take, it's not like going to get, like all of us who have gotten Cisco certifications in the past. It is nothing like that, right?
And let me just speak to that, right? So, back in the, let's call it the Bush administration. When I got my,
Which one?
yeah, I know. That's the whole point, is to be ambiguous about that. When I got my CCIE, why did it take so long? It was a typing contest, and you had to know so much about so much to accomplish so little, right? This is just like, you can think at a much higher level. What important stuff do you need to accomplish? I need to BGP peer with somebody. There's not 20 commands and a bunch of, little options that you can neglect or maybe not neglect. It's just like, all you do is say, I want to peer with this guy. Here's my ASN, done. You've formed a neighbor relationship like that. It boils everything down to the essentials. And now once all you have to do is get the essentials in, suddenly your mind frees up to think at a higher level of like, okay, why are we BGP peering with this guy? And how do we troubleshoot it? And, what are the results of that? So you're going to love it once you catch the hang of it. It's a better way to live.
I have a question.
Shoot.
Internet backhaul. Is that talking about how much internet you have supporting you? What is backhaul?
Backhaul versus breakout. So backhaul is the idea of taking all of your internet traffic, sending it, say, over an MPLS link or a VPN to headquarters. Headquarters has the firewall, and then lets it go to the internet. Breakout is saying, I'm here, and I have an internet connection. I'm going. Perhaps through a firewall, but I'm going, and the headquarters doesn't need to touch this.
Okay.
Better user experience by a lot. Remember my angry wife about why is Concur so slow? That.
One.
Why Concur so slow? Because it's Concur.
Concur sucks, but that's a whole nother.
It's a expense reporting app, isn't it? I used to use that at another company. Yes, it does suck.
Yeah, like, I remember the days when you had to put your receipts all on a piece of paper and photocopy it, right? You send
That's how we do it.
Well, you would think like with Concur is supposed to make your life easier. Sometimes I wish like I could just go back to that. Just let me send you in my receipts.
That's
right?
literally, we just staple them to a cover sheet.
Yeah.
Expensify. It keeps it simple.
Expensify.
Picture of it, organizes it, it prints them all out for you.
Yeah.
$5 a month. And
Yeah,
it'll
well,
read
now-
your receipts for you.
Now that we're with Aruba, you have to do all of your travel through it. And it's like, you run into all kinds of problems because they have all this auto import. So you have a corporate credit card.
Yeah.
That you have, and it auto imports to Concur. And if for some reason it's incorrect, it won't let you submit a report. And you're like, it's.
Yeah.
Okay, let them do their test.
Yeah, I know.
Be quiet, let them finish the survey. Then we can all go home. How's everybody on the phone? Are you accessing the survey? Are you having fun taking the test? Talk to me.
They're like, we're done, man.
I'm done and scored already.
Now you're certified. You're gonna go to the engineering side of the house now?
I'm almost done with it.
100%.
Wait, I'm sorry, was that you, Tony? Say it again, I couldn't hear.
Go ahead, Tony. I think it was Tony.
Tony.
An extra prize for getting 100%.
Huh?
An extra prize?
Prize.
Yeah, you can take 2 classes instead of 1.
Wasn't EJ or Victor supposed to bring like swag or something?
Yeah,
The
Victor had
mouse
sent us
pads
some
and
things,
the,
yeah.
There you go. You should get some swag.
You got 100%. Congratulations. All right, see now, Maria's out there setting the bar real high. If you slackers don't get 100%, she's going to lord it over you.
one. I don't understand the question.
You missed 1? Well, talk to him. Can we do something about it?
Internet backhaul, I was thinking it was the opposite of what it was, so I checked the wrong one. Then Tim asked the question, I'm like, oh, I missed that one.
Well, congratulations, and thank you for taking the test and the survey.
Well, you know, I think they may be, we have some SE positions open.
No poaching, no poaching.
100%,
I was
right?
multitasking, so I don't know how I got 100%.
I blame my score on the avocado.
Okay,
On the turkey avocado. I passed it, but so yeah.
good for
it's
you.
Good.
See, I told you this wasn't gonna hurt. Everyone's passed. I haven't seen anybody surreptitiously like going back for seconds. The turkey avocado only cost you one wrong question. You're doing great.
Now, Tony, you said you had a question at the end, right?
No question. I'm multitasking actually between you and my PM.
Oh, gotcha. Okay. So you're
All right.
squared away on all the APIs, yeah?
Yeah, I did. I appreciate that, and I'll still come by afterwards and ask you a quick question. Okay, Curtis?
Yeah, for sure.
All right. Thanks.
I guess I mean specifically you.
I guess so.
Okay, in all seriousness, do we have comments or questions here before we close? Great job on everybody who passed. Let me hear your final thoughts.
Just one quick final thought regarding earlier about the use of Orchestrator in general. And unless the client doesn't have a specific person, who will be using it, then I think from a sales point of view, to sell that service, like someone said earlier, where they come in now and then to check the monitoring or having to do some kind of configurations, that would be a good sales point if the client doesn't have a designated, department or person that would be the one trained to use the Orchestrator. But even if then, it's not, I don't see that being very difficult to learn.
Well, it's an opportunity for everybody. It's an opportunity if you have an in-house staff to free up their time to do more important stuff. And if you don't have an in-house staff, it's an opportunity for, a partner to say, look, I'll run this for you soup to nuts. We'll stand it up, we'll make it work, and then we'll monitor after the fact for you. We love that. I mean, whatever it takes to make the customer successful and to make partners successful, right? We're all behind that.
Mm-hmm.
Especially Jason. He's more behind the partner part than the customer part. I'm behind the.
There you go. That's right.
What else? What did you see, or what ideas or questions do you have?
What is branch sprawl?
Branch sprawl. Branch sprawl is the concept of like at every branch I've got a router and a firewall and an application visibility device and an optimizer and, right? So your branch just gets more and more complicated. Trying to make all these different devices from different vendors connect together sucks. I mean, I don't know if you're allowed to deal with it, but it's complicated and it's brittle. So the opposite of branch sprawl is thin branch, right? Of just one device at every branch. That's all you need.
I got you.
What other questions do we have? When is he going to shut up and let us go? Maybe never. Maybe never. In all seriousness, thank you. You've been a great class. This has been a good session, good interaction. I think you guys got a lot out of it. I think you're on the right path, and we're happy to help you walk down that path. Let us help you sell something.
Yeah, thank you very much.
Thank you, everybody. Appreciate it. I think we're good. Appreciate it. Thank you. Thank yous. Aruba.